Okay, let's see if we can push through some of these medium difficulty problems. So first one, show unique birth years from patients and order them by ascending. So whenever you see unique, think distinct or use a group by. So select star from patients, and then we're looking at the birth date column. Oh, but we need year, so we need the year of the birth date as birth year, and then we need distinct birth year. Perfect. And then you're going to order that by patients. No, you're going to order that by this. There we go. Does this work? Yes. Okay. Depends on the database, but in most databases, you can just use this in your order by statement or in your order by clause. So you can say, you can name a column and then order by that column. Okay, so here we have it. The other way to do this would be just select the year and then group by the same thing. And it's just going to consolidate all those rows. You're not doing any aggregations, but you could. But here you're just consolidating all those rows and grouping by the birth year, and you keep that order by to order the columns, the column. So that is how we do this question. Oh, was that one of the easy ones? Wait. UL questions. Medium. Okay. Great. Show unique first names which only occur once. So okay, so to find something that occurs one time, you're going to first have to find how many times a thing occurs. So let's look at our patients table. Now, unique first names. So again, uniqueness and counts, that sounds like a distinct, but if we're trying to get counts, you want to use a group by because you want to do some kind of aggregation on that first value. So we want first name, and let's get a count of all the rows as patient count because every row is a patient in this table. And group by first name. And we're not doing a group by this because we are aggregating. So here is your group by column, and here's your aggregation. So you group by the group by column. Okay, now show unique first names from the patients table, which only occur once in the list. So now only occur once means they only have a count of one. So having count star equal to 1. Great. Now it doesn't want us to return the count column, but good news is you can do a group by without referencing the column. So you don't end up with this, but that's how you get to this answer. So that is the answer to that question. How else did they did it? Having count first name equal 1. Yeah. Great. There we go. Great. Next question. Show patient ID and first name from patients where their first name. So again, where first name is this, this, and this. So select star from patients. Okay. So where first name starts and ends with. So we use like to get S at the beginning, any amount of letters, any length, and S at the end. Now, what they implicitly did here is giving you a lowercase character, but that's a problem because, as you'll notice, all of these are uppercase. Now, we don't know for sure, unless we look through all 5,000 results, that every single first name is capitalized. So if someone actually has a lowercase name, you're going to miss it. So what we need to do is convert all these lowercase names to lower. And let's add that as a column here, just to make sure we're doing the right thing. So we can see the lowered version of the column. And then we can see that it's been done successfully. So most databases are case sensitive in the like statement. I use Snowflake a lot, and Snowflake, if you want to do a case insensitive like, you'll use I like. But this database doesn't have that, so it just accepted case insensitive values. But most databases, you need to be careful of doing this because most databases are case sensitive in the like clauses. So just something to keep in mind. Okay, so we've got the list of people where their first name starts and ends with S and is at least 6 characters long. Okay, so there's a function called length. So, and length of first name is at least, so that means greater than or equal to 6. And again, we can just to make sure we're doing the right thing here, we can take that function and plug it into the select so we can actually see that data. And so we've got someone with a length of 6. 1, 2, 3, 4, 5, 6. Looks like they're all Greek. Nice. Or something. Oh, Seamus. We've got an Irish guy. Stanislaus. I don't know where that's from. California. Okay. Great. So now we've kind of figured out our where logic, we are going to get the patient ID and first name. Again, you just hit tab to autofill. And there we are. Excellent. Show patients. First name, last name, patient ID, whose diagnosis is dementia. Their primary diagnosis is stored in the admissions table. So if you look at this table, they don't have diagnosis information. That comes from select star from admissions. Again, if you're using an actual database that's like long, you should always use a limit when you're running your queries like this. So you're only getting like 100 rows or so. You're not gonna make your database run a long time. I'm not gonna do that in this little test database, but it's something you'll start to notice when you run queries and then it pulls like 1,000,000 rows. Always use a limit when you're doing stuff like this, but I'm not going to right now. Okay, so primary diagnosis stored in the admissions table. So we need to get the patient ID. Well, think about it like this. How do we connect these two tables together if this one has the patient ID, first name, last name, and then this table just has their diagnosis information? Well, we have to join these two tables together on some sort of ID. So what is that ID? We were talking about the patient ID in this case. So it's like patient ID and the diagnosis. Yeah, if there's 2 here, you have to select one and then you can run it. Okay, so we've got the patient ID and the diagnosis. Let's call this A. And we're going to call this, say this is A dot and A dot. So this is the alias of the table name. And then we are saying admissions table patient column, admissions table patient column. We're going to do that because we're joining this to this. So same thing here. We're going to get the patient ID, first name, last name, and we're gonna also alias this table, so as P, and then each one of these we're gonna say P dot, P dot, P dot. So you know these are the columns that are coming from this table, and these are the columns coming from this table. And now it's time to join these together. So what is the relationship between these two things? So you've got a patient, and you've got an admission. Oh, we have duplicate admissions. So how do we get the primary diagnosis? Let's look at the, so we've got a patient with two things, and primary diagnosis stored in the admissions table. What are they asking for? Are they asking for the latest diagnosis? Or are they asking for the every diagnosis? Or I guess, okay, no, here's the thing. Patients can't be diagnosed with, I didn't realize it was dementia. So people can't be diagnosed with two of the same thing, right? So we're going to say where diagnosis equals dementia. Perfect. We should only have one row per person. We can check that by doing a count star, and then group by star, order by count star ascending. Oh, can you not group by star? Patient ID. All I'm doing here is I'm ordering by descending and checking to see if there's anyone who has more than one diagnosis of dementia. It looks like they don't, so important to check that kind of stuff, or else you'll end up with a wrong answer. Okay, so because you can, I might just assume that someone doesn't have more than one dementia diagnosis, but if there is one because the data's bad, then you're going to end up with duplicate rows when you do your join. Okay, so again, we have A.patient ID and A.diagnosis now that we have the right where criteria. So by missing that criteria, it made the request a little more confusing. Again, A.diagnosis is what we're calling this. And now we're going to join these two together. So how should these be joined? We can use an inner join here because we want people who are both patients and have this diagnosis. And so it doesn't matter if there's no way we're going to be filtering out anyone that we don't care about, if that makes sense. So I'm going to pull this up to the top one, and then we're going to inner join admissions. Oh, as. You don't have to use an as, but I like to. So from patients as P, inner join admissions as A. Now how are you joining these two tables together? You're going to join them on the P.patient ID column equal to, so wherever the patient ID is on one table is equal to the patient ID on another table. So on the A table, patient ID. Okay. And then you need to bring in that same where criteria. So where the admission diagnosis is dementia. And run that. Okay, we've got patient ID. Now we've got two patient ID columns. Do we need those? Well, once we verify that they match up, this was our join criteria. So we've joined correctly. They are matching up. We can now just get rid of this. We'll delete that, run that. We have patient ID, first name, last name, and diagnosis. Now, we don't need their diagnosis column, so we can just comment that out, but it's there, so we know we have it. And there we go. They did an inner join here as well. I really don't like just using the word join, because you will forget exactly what you're doing, because here you Warning, you may be filtering out important data. Now, if your criteria is that they have to be in both tables, then a join makes perfect sense. It's actually the most efficient way to do filtering, because you're basically filtering for only patients with this diagnosis on that other table. So if you're using a join to do a filter, then an inner join makes a ton of sense, because if you're doing a left join here, you're going to end up with a bunch of people who don't have oh no, you are still going to have it. Never mind, because you're using the where. Okay. Anyway, you can use outer join here, but inner join here makes sense if you're just trying to filter for only people with certain criteria. Okay. Every patient's first name, order by length, and alphabetically. Sounds complicated. Are you tired of the patient's table yet? Okay, we want first name. And let's get the length of, I assume when they say length of each name, they mean the first name. And then order by alphabetically, so you can just order by this, and that'll be alphabetical. So let's do that first. Great. So now we can order by length of first name. They don't say if they want the biggest or the smallest first. Let's just go with the default, which is ascending, so smallest to largest. And then the first name. And then we can leave this column in just to see if it did what we wanted. It did. So the people with 2 letters. 2 letters and then alphabetical. Great. So that did what we wanted. Now we can get rid of that, and we end up with the desired end state. Okay. Display the 2 results in the same row. Show total amount of patients, male patients, and the total amount of female patients in the patients table. Oh, so we're going to use a case statement here. So I'm going to teach you about a case statement. So a case statement is basically an if statement to define what's in a given column. Okay, so the syntax for a case statement is case when some logic, then do this, and then end the case statement as a case column. So for example, case when the gender is male, what are we going to do then? Well, we want to sum up those rows. So we want, or get a count of those rows. So we're going to get a row count. Again, every row is either male or female, so we can just get a count star. I think I might be messing this up. We'll see in a second. Else 0. Oh, you know what we're gonna do? Well, let's try this, because it might not work, and then I'll realize, oh yeah, that's why it's not gonna work. As gender men count. Did that work? No, because remember this has like 5,000 columns, so what it's doing is it's going, okay, I saw the first row is a man, so I did a count star of all the rows. So I defined some logic that was bad. What I need to do instead is say, if the gender is male, then 1, else 0. But that's not what we want. We wanted a total. So we're going to do a sum of everything inside that case statement. we're going to get the total number of men. Does that look better? It looks like about half of the people, which would make sense because half are going to be women. So we did the same thing. When gender is female, then we're going to have it be a 1. Otherwise, 0. And then we are aggregating that whole column as female count. Great. Now let's go back and show you what we're actually doing here. Patient ID and patient name, or first name. Let's do a group by patient, well, 1, 2. Column 1, column 2, because I am lazy. Okay, so as you can see, what we're doing here is we're saying, okay, patient 1, if the patient is a man, let's pull up the gender flag. Not that kind of gender flag. Okay, we are pulling up patient ID, first name, and gender, and what we're saying, case or if, when their gender is male, which it is here, then 1. Otherwise, 0. So here you can see the otherwise is 0, and you can be explicit. So when gender equals female, 0, and that'll do the exact same thing. So, but this is, since I know there's only 2 options in this table, then I'm just saying else. So if this, then 1, otherwise end. And we can check to see if that's the case by summing up all of them. So sum, or count star, it should be every single row. We'll get rid of our group bys. And this plus 2062 should be 4530. Okay, so our assumption was correct in our else logic here. So I hope that kind of makes sense. All we were doing is we were what did I do? Patient ID, first name, gender, oh, here we go, same comma. All right, so again, all we're doing is we're kind of creating a little flag here. So this is a man, this is a woman, and then we're summing up all those flags from the patients table. So we're doing a sum of every flag to get the count of men and women, and that was the answer to that question. Oh yeah, that's another way to do it. Okay, so another way to do this, instead of using a case statement, is to do subselects. This is where you say select, and then that's just to say, hey, I'm starting a query. And then you're gonna do 2 separate select statements underneath here. So you're gonna say select count star from patients table where the gender equals male. And then you're going to put some parentheses around that. And you're going to call it man count. And then comma. And just do that whole thing again. Where gender equals female. Woman count. And you'll get the same answer. I tend to prefer case statements because these can get a little bit unintuitive. Like you've got 3 select statements here. I don't know what to do with that sometimes. So, and you usually have other types of data. You're not just trying to get a count. So anyway, oh, here we go. So select sum of gender equals m. Oh yeah, I guess you can do that. Okay, you didn't need a case statement. You just needed gender equals male, I guess. I didn't know you could do that. And then here's my case statement solution. So the sum of case when gender is male, then 1. And you didn't even need else logic. You just do end, because you don't need to add up a bunch of zeros. You just that would make everything else null, which would be the same if you're adding up columns and rows. So that is that. Okay, I'm gonna take a break. This is part 1 of medium difficulty practice problems.